Let's look at question number 3, find x. This is the hypotenuse. Now it's important that we're given some information here. We need to know that the side lengths are 1. So in this isosceles triangle, we're going to use the Pythagorean theorem. X squared is equals to 1 squared plus 1 squared. So therefore x squared equals 1 plus 1, which is 2. So x is equals to the square root of 2. Theta is simply 45 degrees because we know that 45 plus 45 plus 90 is 180. As for this triangle here, sine theta, this is simply SOHCAHTOA, right angle trigonometry, is equals to opposite over hypotenuse. So the answer is 5 over 13. Trigonometry, sine cos tan, is simply a ratio of two sides. SOHCAHTOA, sine is opposite over hypotenuse. We use the cosine acronym, AH, adjacent over hypotenuse. Cosine theta is adjacent over hypotenuse. Now to figure out this adjacent, we have to use Pythagorean theorem again, which gives us 12. 5, 12, 13, using Pythagorean theorem. So cosine is adjacent over hypotenuse. Tan is opposite over adjacent, which is 5 over 12. Opposite over adjacent. Now what about theta? It doesn't really matter which of the trig ratios we use. We'll just use sine, the first one. You just hit that sine inverse button. Theta is equals to sine inverse of this number here, 5 over 13, which is approximately 22.6 degrees. Now what's cosine inverse? Now let's focus on adjacent over hypotenuse. Cosine means adjacent. So adjacent over hypotenuse, we're talking about this angle here. We'll call this alpha. Cosine of alpha is equals to adjacent, which is 5, over hypotenuse. So we'll say alpha, cosine of alpha is equals to 5 over 13. So when you hit the cosine inverse button, essentially you're finding alpha, which is what the question is asking for. Alpha equals cosine inverse of 5 over 13, which is simply an angle. And it's going to be 180 minus 90 minus theta, which is approximately 67.4 degrees. Visit hunkim.com/10 for more primary trigonometric ratio practice problems. Now it's your turn. Try part A, B, and C. Pause the video.